In this video, I want to do some quick examples where we graph some lines when we're given their equations. So in part A, I have these two equations. So let's start with the bottom one, y equals 3x. Well, I can see that the slope is 3. And then because there's no number written here where the b usually goes, that means b is 0. So my y-intercept is 0. It goes through the origin. And then I got my rise over run. I got 3 for the rise over the run of 1. So it's going to go through this point. If I draw one more of these now, kind of going this way, if I go 1 to the left, I would go down 3. So it's also going to go through this point. And if I connect these, I get my line. Okay, so that is my y equals 3x line. Y equals 3x. Okay. And then x equals -3. That looks a little weird because there's no y's in that equation at all. What that means is every single point on this line has x coordinate -3. So I know x is -3, that's over here. What does a line look like if every single point on it has x coordinate -3? Well, it's just going to be a vertical line. Every single point on that vertical line has x value -3. So that is x equals -3. Similarly, if I had a horizontal line, every point on that has the same y value, that equation would be y equals whatever that y value is. Okay, let's do part B. So for this one, the problem gives me a hint. It says for B and C, start by converting the equation into our slope-intercept form using some algebra. So remember, slope-intercept form looks like y equals mx plus b. And to put this into that form, we can split up this fraction. So I got y equals, and I can write it as x over 2 minus 3/2. Right? Because if I'm subtracting two fractions and the denominators are the same, I can just subtract the numerators to get this over that one denominator. And I can rewrite this first term. Or, this is the same thing as 1/2 times x. And that's nice because I see that the slope is 1/2. And the y-intercept, so this -3/2, if I write that as a decimal, that's -1.5. I don't need to do that, but it just helps me get a sense of where should I draw it. So it's between -1 and -2. So -1.5 would be somewhere here, somewhere there. And then my slope is 1/2. So when I go up, rise of 1, the run is 2. So it's going to go through this point. And again, if I go up 1 and over 2, it'll go through that point. And if I connect these, I'll get my graph. I'll get our graph of this line. Okay, so one more. Part C. 4x plus 3y equals 6. Okay, so this line equation is given in standard form, but to graph it, it's helpful to put it in slope-intercept first. So for this one, I want to give you a quick 2 minutes to pause it and try it. So pause it in 3, 2, 1, pause it and try it. This is the most important part of the video. It gives you a chance to see how well do I understand this stuff right now. It's totally fine to get stuck and have questions, but it's important to engage with it and see how much progress you can make. Okay, so let's talk about it. So to get it in y equals mx plus b form, I got to get the y by itself. So I'm going to move the 4x over by subtracting. So I'll get 3y equals -4x and then plus 6. Now I got to divide both sides by the 3 to isolate y. So now it's going to cancel the 3 on the left. I get y. And on the right, I can do the same thing with this fraction that I did with this fraction. I can split it into 2. So that's going to give me -4/3 times x. And then plus 6 over 3, which is just 2. So I see that the y-intercept is at 2. That's up here. And then the slope is -4/3. So I go rise 1, 2, 3, 4, down 4. And then over 3, 1, 2, 3. It's going to be going through, this point here. And if I connect those, my graph is looking something like this. And there we have it. That is our line.